Hey guys, this is Mrs. Butcher, and this video is all about using combinations. Alright, so the definition of a combination is a selection of R objects taken from a group of N objects where order is not important. So, when we did permutations, order mattered. We were talking about the first number and then the second number and then the third, like in a phone number, or first place and second place and third place, where order is important. But if it's not important, if it doesn't matter, I'm just gathering a group of things and it doesn't matter which one is first, second, or third, that's a combination. And so when we have combinations, the number of combinations of R objects taken from a group of N distinct objects is denoted by NCR. Remember, when we did permutations, it was NPR, and now we have NCR, and that's a different formula, so another one you've got to know. NCR equals N factorial over N minus R factorial, and then times another R factorial in the denominator. I also want to let you guys know that you can do this in the calculator, but you do need to have this formula memorized. But if you wanted to do NCR in the calculator, you're going to type in whatever number your N is. Say we were doing 5C2. Then you would hit 5, and then you go math, and then choose the PRB, the probability option, and then I think it's number 3, NCR. And then you put in whatever number your R is, so in this case you'd put the 2. So that when you type it in the screen it looks like this, 5NCR2. And then you hit enter and it will do it for you. So you do have that option of using the calculator, but you have to know this formula. Alright, so let's do an example. You are picking 7 books from a stack of 32. If the order of the books you choose is not important, how many different 7-book groups are possible? So instead of counting out, making a tree, figuring out all the different combinations we could possibly have, you can use the combination principle, NCR, and we have N equals 32 books, and we are choosing R equals 7 of them. So we're going to do 32 C7. That means we're going to do 32 factorial on the top, and 32 minus, that should be a 3, 32 minus 7 factorial times 7 factorial. That gives us 3,365,856 possible groups, possible 7-book groups. Alright, now if we're trying to find the number of ways that both an event A and an event B can occur, we would have to, you can scratch out this as in part B of example 1, you would need to multiply. We would need to find the combinations of A and then multiply that by the combinations of B. If we were finding the number of ways that an event A or B could occur, you would add instead. You would take all the combinations of A and add them to all the combinations of B. So when you're adding them, it's an OR situation. But if it's both, you have to multiply. Because you could have more combinations that way. Alright, here's a real blast from the past. Does anybody remember this place, Blockbuster Video, where we used to go get our movies before we had Netflix and Amazon and all the online stuff? Well, this problem was written back in those days, but the local movie rental store is having a special on new releases. The new releases consist of 12 comedies, 8 action, 7 drama, 5 suspense, and 9 family movies. Alright, so you go in there and you want exactly 2 comedies and 3 family movies. How many different movie combinations could you rent? And then part B says you can afford at most 2 movies. How many movie combinations can you rent? Oh, look at the typo. Sorry about that. So how many movie combinations could you rent if you could only afford 2 movies? And this is separate from A. You're not limiting yourself to 2 comedies and 3 family. Alright, so part A. This is an and situation. You want 2 comedies and 3 family movies. So we know that we're going to be multiplying. for the comedies, we want to choose 2. And there are 12 comedies to pick from, so we're going to do 12C2. 2 out of 12 comedies, and then we're going to multiply that by the combinations of family movies. There are 9 family movies, and we're going to pick 3, so 9C3. We're going to multiply 12C2 by 9C3. When you put those in the calculator, you get 66 and 84. And 66 times 84 is 5,544, 5,544 combinations. That's a lot of different combinations you could possibly watch. Alright, part B. You can only afford at most 2 movies. How many movie combinations could you rent? So you could rent 0 movies, right? That's one situation. Or you could rent 1 movie, or you could rent 2, because it says at most 2. So we need to add each of these groups together. So if we don't buy any movies, out of 41, we're going to do combinations of none. And if you punch in your calculator 41C0, you get 1. There's one way that you can buy no movies or rent no movies. Then we're going to add that to 41C1, the combination of 1 out of 41. And there are 41 different ways that you could get 1 movie. And then we're going to add to that the combination of 2 out of 41, so 41C2. And when you plug that into the formula, or if you want to use your calculator, you will get 820. And so when you add 1 plus 41 plus 820, because that's none or 1 or 2, we have 862 different combinations of 0, 1, or 2 movies. So when you have or, you add, and when you have and, you multiply. Make sure you know that. Alright, and the last way we're going to do some combinations is subtracting the possibilities. Counting problems that involve phrases like at least or at most are sometimes easier to solve if we subtract possibilities from the total instead of trying to add up all the different ones. For example, a popular magazine like Math Magazine has 11 articles. This has got Justin Bieber on it. It's so awesome. Alright, you want to read at least 2 of the articles. How many different combinations of articles can you read? So based on the problem we just did, we say, okay, well this is at least 2, so we could read 2, or 4, 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10, or 11, because there's 11 total. You could add up all of those different combinations, or you could just figure out how many combinations there are altogether, but then subtract the possibilities for 0 or 1, because those are the only 2 options you're not going to do. That, to me, sounds easier. So if you think back to what we learned a couple days ago, we're going to read at least 2 of the articles, and it has 11 articles. So we could read 2, or 2 different ones, or 2 different ones, and there's 11 different articles. It's 2 times 2, 11 times, 2 to the 11th power. There are 2,048 total combinations of articles that we could read. Okay? But out of all those total combinations, I'm going to subtract away the combination of having none, 11C0. I'm going to take that away because I'm not going to read none. And I'm also going to take away the combination of having 1 because I'm not going to read just 1. I want to read at least 2. So I've got 2048, and then I'm subtracting, that's 1, and that's 11. So 2,048 minus 1 and minus 11 gives me 2,036 possible combinations if I read at least 2 articles. And hopefully I'll get to read the one about Justin Bieber. So when you were putting this in your notes, your little key word or phrase that I'm going to ask you about is who's on the cover of Math Magazine, and you're going to tell me it's Justin Bieber. Alright, so that's it for this video, and I will see you guys at school tomorrow.